Hello, middle school algebra students. We are going to be doing a review here of solving linear systems. And so basically what that means is that we're just going to solve or find out where two lines cross. That's our goal. But we're going to do it using the equal values method, which is going to be kind of an algebra focused piece. So far we've used a lot of tables. We've seen graphs using Desmos. But sometimes the algebra approach is going to be your best approach. So that's what we're going to look at here first. Okay, so our first one says this. Solve the following linear system using the equal values method. Write your solution as an ordered pair. Quick little thing of note here. This equal values method, this is also referred to as substitution. So if you were to do a search online because you wanted to see some other method or see somebody else do it, you'd want to use the word substitution. So basically what's going to happen in this method is this, is you have these two equations here, y equals 2x plus 10 and y equals 4x plus 18. And you're just trying to figure out when these two lines, because if we were to graph these, let's just make a straight line, I want to find out where these cross or where they're equal. So I just need to figure out where this part, 2x plus 10, is equal to this part, 4x plus 18. I do that by just setting them equal and say, when is this equal to this? So my first one, 2x plus 10, I'm just going to set that equal to the second piece, 4x plus 18. Now, it may not look like it right here, but this is just an algebraic equation that I can solve. I just need to get x onto the same side first, and then get it by itself. So I like to start with the smaller x value. So on the left side, 2x is smaller than on the right side, 4x. So I want to try to create a zero pair on the left side and remove the 2x. So if I've got positive 2x to remove it, I need to subtract 2x. But since this is an equal sign, if I do it to one side, I need to be sure to do the exact same thing to the other side, or I will not maintain my balance. So when I do this on the left side, positive 2x and negative 2x is a zero pair, so that goes away. I've got a positive 10, that stays the same. 4x take away 2x, well, that's just going to be equal to 2x. And my positive 18 on the right side also stays the same. Now this looks a little bit more like a 7th grade problem here. So now I just need to get the x by itself. So I need to get rid of this 2 and I need to remove the 18. So to get rid of the 18, I need to do the inverse operation, create a zero pair. So positive 18 take away 18. And if I do it to one side, I need to do it to the other side. That creates a zero pair. 10 minus 18 on the left side would be equal to negative 8. And then I just drop down my positive 2x. Now my very last step, if positive 2x, so if 2x's or 2x rectangles is equal to negative 8 cubes, then I just need to split those 8 cubes, or those negative 8 cubes, into two groups to find out what 1x is. But if I'm splitting the left side into two groups, I need to split the right side into two groups, which will give me that x will be equal to negative 4. So this is one half of my solution here. To find the other half, to find the y value for the solution, I would need to take and solve this again. But this time I'm going to take the negative 4 and I'm going to plug it into either of the original two equations and then solve for y. So if I use the top equation, y equals 2x, well, x we said was negative 4 plus 10. So 2 times by negative 4 is a negative 8 plus 10. So negative 8 plus 10 would be a positive 2. Y should be equal to 2. So my solution in this is going to be negative 4, positive 2. And we always write that solution as an ordered pair. So just like I have it here, parenthesis, negative 4, comma, 2, and then put the parenthesis to close it off. Let's see the next one. The second problem here, number 2, says this. Xavier has $40 and is saving $10 per week. Lauren has $160 and is spending $5 per week. Part A says write a linear system that represents a situation where x equals the number of weeks and y equals the amount of money. So our first piece is just to write the equation. So this is what I really want you to try here. Remember, we write equations in y equals mx plus b, where b is going to be what my starting value is, and where m is going to be what's changing. What's the change? So pause the video here. See if you can write the equation for Xavier. Remember, he has $40 and is saving $10 per week. See if you can write the equation for Xavier. All right, so we're going to work on Xavier's here. So the change, Xavier is changing $10 per week. It's dependent upon X. So I'm going to put that $10 right next to my X. 10 times by X. And if it's 2 weeks or 2X, that'd be $20 that he's saved. Then we take this $40 that he started with. Doesn't matter if he's at week 0 or if he's at week a billion. He still has the $40 that he started with. So our equation would be y equals 10x plus 40. Now pause the video again, and why don't you try writing Lauren's equation this time. Try writing Lauren's equation. Okay, so Lauren's equation is going to look much the same. Y equals whatever my change is, m. Well, Lauren is spending $5 per week, so it's going to feel like we should say 5x. But remember, she's spending, so that should be a negative 5x because she's losing $5 per week. And I shouldn't say a negative 5x, it's a negative 5. X is the number of weeks. So m is just the number, it's never the x. M is just the number. Then it says that Lauren has 160. So she's starting with $160. So Lauren's equation is y equals negative 5x plus 160. Now, part B says use the equal values method to solve the system. So again, I'm just going to take these two equations and set them equal to each other. So I'm going to take Xavier's 10x plus 40, and I'm going to set that equal to Lauren's, which is negative 5x plus 160. And now I just need to solve it. So remember, get x's on the same side and then get x by itself. I like to use the smaller x value because it helps me keep my numbers positive. So negative 5 is smaller than positive 10. So I want to move the negative 5. And I'm going to do that by doing the inverse, or doing the opposite to create a 0 pair. Negative 5x, if I add 5x, that'll create a 0. But if I do it to one side, I need to do it to the other side. So 15x on the left side. My negative 5x and positive 5x create a 0 pair. And everything else is going to stay the same. So I end with 15x plus 40 is equal to 160. Now still trying to get x by itself. So I need to remove the 40. It's a positive 40. So I do the inverse or opposite to make a 0 pair. And I'm going to do it to both sides. So my 15x is the same. My positive 40 and my negative 40 have turned into a 0 pair. 160 take away 40 is 120. So my last step is just, what is 1x equal to? I've got 15 of them, but I'm looking for just one of them. So I need to split the 120 into 15 groups to find out what 1x is equal to. So I'm going to divide each side by 15 to maintain that balance. X in this case is going to be equal to 8. If you don't know that off the top of your head, use a calculator. Calculators are your friends. They are very good at helping you solve math problems. Now remember, this is just my x, so I'm not quite done yet because it says that I need to write my solution as an ordered pair. Well, an ordered pair is xy. Well, I've only got the x. I don't know what this y is equal to yet. So I'm going to plug the x back into one of the original equations, either into Xavier's or into Lauren's, and solve it for y. So over here, I'm going to solve for y. So let's just use Xavier's because it's got all positive numbers. Y will be equal to 10 times by my x value, which is 8, plus 40. It doesn't matter which equation you use. I just chose Xavier's because I like to keep positive numbers. So 10 times by 8 would be 80. 80 plus 40 would be 120. So my solution here as an ordered pair is going to be 8, 120. 8 comma 120. My y value is 120. My x value is 8. And then our last piece here is we need to write your solution as the ordered pair, but then also explain the meaning of the solution in context. Well, here it told us what the stuff was. It says x equals the number of weeks and y is the amount of money. So just all we need to know is that at 8 weeks, both Xavier, let's see here, I need to see how to spell that. Xavier, because I am not a great speller. Xavier and Lauren have $120. So at 8 weeks, Xavier and Lauren both have $120. Okay, here we go. The third question. The population of the city of Nishuda is 1,160 and is growing by a rate of 22 people per year. The population of the city of Delafield is 1,900 and is decreasing by a rate of 15 people per year. Write a linear system that represents a situation where x equals the number of years and y equals the total population. So very similar to our previous one. So we're going to have Nishuda and we're going to have Delafield. I want you to try and write those equations first. We really struggled on this on the Chapter 4 test, so this is why I want you to try this before you watch it. So try it on your own first. Okay, so you should have come up with equations that look like this. So Nishuda is gaining 22 people and starts with a population of 1,160. Delafield is losing 15 people, but is starting with a population of 1,900. So we've done part A. Part B, use the equal value method to solve the linear system. So again, I'm just going to set these two things equal to each other and then solve. So 22x plus 1160 should be equal to negative 15x plus 1900, or 1900. I'm just taking the two populations and I'm just going to set them equal to each other and solve. So again, I like to take the smaller x value and move that because it keeps my numbers positive. So 22 is bigger than negative 15. So I'm just going to add 15x to create a zero pair. But I need to do it to both sides to get 37x. My rest of the equation is all going to stay the same. 1600, negative 15 and positive 15 becomes a zero pair. 1900 is left over. Now moving forward here, I'm just trying to get x by itself. So I'm going to get rid of this other, well, not 1600, but 1160 onto both sides. I'm going to create a zero pair on the left side, and I'll be left with a positive 37x on the left side. And on the right side, I'll be left with 740. If you didn't know that, just use a calculator. Not a big deal. Just use a calculator. Another great example of when to use a calculator. I need to split 740 into 37 groups because I want to find out what 1x is equal to. X is going to be equal to 20. Now remember that solving for x is just part of the solution. I need to know what the y is as well. So again, I'm just going to take that x value and I want to plug it into either of my two equations. Doesn't matter. Again, I'll probably take the top one, the 22x plus 1160, because all the numbers are positive and I just like to keep numbers positive. Just feel like I make less mistakes that way. So y equals 22 times by our new x value, which is 20. Then I've just got the rest of the equation, which is plus 1,160. So now I've got 22 times by 20. That would be 440. And then I just need to add that to my original 1,160. So my y in total is going to be 1,600. So my ordered pair will be my x value, which is going to be 20. And then it's going to be my y value, which is going to be 1,600. Now the last part here again is that it says in context. What does that number mean in context? What is the meaning of the solution in context? What does 160 mean? Well, what that means is this. At 20 years, the two cities have 1,600 people for population. And that's it. Let's take a look at the last one. Okay, question number 4 here. Solve the following linear system using the equal values method. Write your solution as an ordered pair. Okay, well this feels like what we've been doing here. So, you just take your two equations and you would just set them equal to each other. So now I've got 4x plus 6. That should be equal to negative 2x plus y. Now something looks different here. This y value is going to throw us off. If I try to solve this for x, I won't be able to get down to a number because I've got this second variable of y here. So for the equal values method to work, you need to have y equals or x equals on one side, and that's it. Because what you're actually doing is a method called substitution. You're actually substituting all of this information here in for y or in for x, depending on what you're solving for. Y is equal to that. So just like we could say y is equal to 6, and we take the 6 and we just plug it in there, well, why couldn't y be equal to 6 plus 2? Well, then you just put in 6 plus 2, and then why couldn't y be equal to 6 plus 2x? And then you just plug in 6 plus 2x, all for y. So that's why it's called substitution method. We'll see more about that in some later chapters. So our first step here is we need to get both of these equations to be in y equals, meaning that I need to solve this one for y first. So I've got negative 2x plus y is equal to 32. So to solve for y, to get y by itself, I just need to get rid of this 2x. Do the inverse operation and add 2x to both sides to create a zero pair. Y is going to be equal to, and I always write my x first just because I just like it that way more. It doesn't matter if you write it as 32 plus 2x, but I just usually write it first. So my new equation here is this one. Y is equal to 2x plus 32. Now I've got my two equations that I can set equal to each other and use equal value method, not theorem. So my first one, 4x plus 6, I'm going to set that equal to my new thing that I just found, 2x plus 32. Now it's just some fun with algebra. So I'm going to take the smaller x value, which is 2x, and I'm going to move that onto the other side. So I'm going to subtract 2x to create a zero pair here. Positive 2x and negative 2x, that cancels to be a zero pair. 4x minus 2x on the left side is equal to 2x. On the left side, my positive 6 is the same. And on the right side, my 32 is the only thing left over. Then on the left side, I'm trying to get the x by itself. So I'm going to remove the positive 6 that's on the left side. I'm going to remove it from both the left side and the right side. So now I've got 2x on the left side will be equal to 26, because 32 minus 6 will be 26. My very last step is to split that 26 into two groups so that I can find out what 1x is equal to. X will be equal to 13. Now remember, that's just 1/2 of the solution. So to find the y value now, I need to take that x and plug it into either of my original two equations. Let's try plugging it into the second one, because like I said, I like to keep it positive. So 4 times by my new solution of x, which is 13, plus 6, all of that should be equal to y. So 4 times by 13 would be 52, plus 6, that should be equal to 58. Y will be equal to 58. So writing it as an ordered pair, my x value, let's see here, my x value will be 13. My y value, which I'm going to do in blue here, will be 58. So my solution would be, in parentheses, 13 comma 58. And that is everything. That's it. Have a great rest of your day.